All right, so we have two triangles that are similar to each other, and we have to find the value of x, and also find the measures of line segments AC and CE, which are the distances of this line, which is the hypotenuse of this blue triangle, and from C to E, which is the hypotenuse of this yellow right triangle. Now, one reason that we can see that these triangles are similar to each other or proportional to each other is if we were to take this blue triangle and rotate it 180 degrees and then dilate it or scale the size up, we could see that it would fit perfectly with the larger triangle, that they would be congruent. So really, this blue triangle is just a scaled down version of the yellow one, all right? So what we're going to do here is we're going to set up a proportion to start. We're going to find corresponding sides and write those as ratios. For example, the height of this blue triangle is 4. And we're going to compare that to the height of the yellow triangle, which is 6. So we could say that the ratio of their distances is 4 to 6, which could be reduced to 2 to 3. And we know that is going to be equal to the comparison of another pair of corresponding sides. So on the top here, we started with a side from the blue triangle. So we have to do the same for this ratio over here. So let's go to this hypotenuse here. We're going to say that the ratio of x plus 7 compared to 12 minus x is equal to 4 to 6. All right, what we're going to do now is set up an equation by understanding that when you cross multiply with a proportion, you should get equal quantities. So we're going to multiply 4 by 12 minus x and set that equal to 6 multiplied by x plus 7. All right, now what we're going to do is apply the distributive property. We're going to multiply 4 by both terms inside the parentheses here. That would give us 48 minus 4x. And over here, we would get 6x plus 42. And now what we have to do is just isolate for x, and that will tell us what the value of x actually is. All right, so the next thing I'm going to do is I'm going to take this 4x, this negative 4x, and I'm going to write the inverse of that so we can send it to the other side of our equation. That gives us 10x plus 42 on the right side, and over here we're left with 48. Now we're going to take this 42 and subtract it from both sides, and that leaves us with 6 equals 10x, and then we divide both sides by our coefficient of x. So we divide 10 by itself, and we divide 6 by 10. All right, now 6 over 10 can be reduced to 3/5. So we can say that x is equal to 3/5, which is the same thing as 0.6 as a decimal. All right, so the next thing that we're going to do is figure out what the distances are of line segments AC and CE. So we're going to take x plus 7, which is what AC is equal to, and we're going to substitute 3/5 in for x. Let's convert this to a decimal though. So I'm going to write it as 0.6 plus 7. So we're going to say that line segment AC is equal to 7.6. All right, now for line segment CE, which is equal to 12 minus x, we're going to write 12 minus 0.6, and that would give us a distance that is equal to 11.4. All right, so we determined what the value of x is, which is 3/5 or 0.6. We also determined the length of line segment AC and the length of line segment CE.
Hey, I just want to say thanks for checking out this math tutorial. Please don't forget to hit that subscription button and enable notifications so you can be informed as I upload new math tutorials to my math channel. Until next time, this is Shane Masonette with Masonette Math.